This lab is called Is Momentum the Full Story? So we know that momentum is an object's tendency to keep moving, right? It's a product of mass times velocity. We're going to look to see if that's the full story of what's going on when objects collide with each other. So at each table, what you're going to have is you're going to have like a blue ramp with different notches on them, which will roll an object down at different velocities. You're going to have a cup with one of the sides cut out. We're going to measure how far that the objects push this cup. We're going to have two different meter sticks on each side just to sort of guide the cup so we can get an accurate measurement of how far that object travels, and we're going to have four different objects. You're going to have a table tennis ball, you're going to have a glass marble, a metal marble, and a golf ball. Now, when measuring how far the object travels, make sure that the edge of that cup, where we're starting to measure that cup, is on the 0 mark on the meter stick. Now, you can move this blue ramp forward or back depending on like how large the object is or if it starts to bounce out, but you want to make sure that that edge of the cup is on 0. Now, when you roll an object down and it pushes that cup, you want to make sure that you're measuring that cup at the edge as well. That'll be how far it travels. For the first test, we're going to change the mass of the object rolling down the ramp. Now, for all four of those objects, you'd want to get a digital balance and find the mass of it. I'll go ahead and put that in the data table after we do this experiment. So for this experiment, we're going to roll all four of those objects down the ramp at notch number 2 to ensure that they're hitting the cup at the same velocity. Now I'm going to do 3 different trials for each just to reduce some of that random error. So I'm just going to do that table tennis ball first. Next up is the glass marble. Next up is the metal marble. Last up is the golf ball. Now that we've rolled all 4 objects down the ramp at notch number 2, we can look at our data table. Now, using this data, we can graph the mass and the average distance that object pushed the cup. So this is that graph. For this next section of this lab, we'll only be using the metal marble. The rest of the objects, we can put them aside. Now we're going to be rolling the metal marble down the different notches. So 1, 2, 3, 4, and 5. Now when you get up to 4 and 5, that gets a little bit tricky because sometimes it bounces out of the cup, sometimes it like rolls the cup, sometimes it gets stuck on the meter sticks. So that one takes a little, you might have to do more than 3 just to make sure you get it. But we're just going to do 3 trials at each notch, and we're going to put that in a data table and graph that. So now we're going to change the velocity. So I'm going to go notch number 1. Next up is notch number 2. Now we've already done notch number 2 in the previous one where we tested the math. I'm just going to redo it just so we can get some more data. So here goes notch number 2. Next up is notch number 3. Next up is notch number 4. Next up is notch number 5. Remember, for notches 4 and 5, those can be a little bit tricky because sometimes it bounces out of the cup. You want to make sure that the marble stays in the cup the entire time and it's not ricocheting off the side of the meter sticks. tried to do that one more than 3 times just so I could get a good one, but once you have 3 good trials, you can find the average. Now that we've done the metal marble at all 5 notches, we can graph the velocity that marble hits the cup at and how far it traveled. So we can take that data table, and this is the graph that data table would make. Now that we have both those graphs, the first one where we changed the mass of the objects and we measured how far that cup was pushed, one where we changed the velocity and we saw how far that cup was pushed, we can look at these 2 graphs. Let's compare these 2 graphs to different types of graphs. Right, so we can look at one that's a linear, we can look at one that's like a negative linear, one that's squared, one that's inverse squared, and let's take a look at both of these graphs and compare it to these graphs and see what each of them look like. Now, based on the graphs that we made and the graphs that we're looking at, we should be able to answer the question, is momentum the full story, or is there something else at play here? So once again, this lab is called Is Momentum the Full Story?